Hi, we're Group 7 and we're presenting Workshop Week 4, First Order Differential Equations. I'm Sajneet and I'm doing question 5. Assuming that only fresh water flows into the lake, i.e. when C in is equal to 0, solve equation 2 where Q is given by equation 3. So this is equation 2 and equation 3, and CIN is equal to 0. So basically what we have to do is sub equation 3 into equation 2. So we'll write out equation 2 factorizing the Q out of the C's, and rewrite it with using equation 3 plus E cos 2 pi t all over 365. Okay, now when CIN is equal to 0, this goes away and you're left with negative C. So we bring the negative C down here and bring the V over here, and also the dt up here. dt. And now we integrate both sides just to get C on its own. Get negative ln C, which is equal to sine, and then you times it by the coefficient, the reciprocal of it, and add a constant. We want to find C on its own. We go ln C is equal to negative Q naught on V t squared plus t 365 all on 2 pi sine 2 pi t all over 365 minus k, because we bring the negative over. Now we put everything here all to the power of e, so the e and the ln cancel, you're left with c, you're left with, on this side, e to the power of negative q naught v t squared on 2 plus e 365 all over 2 pi sine 2 pi t all over 365 minus k. And because of law of indices, e to the negative k is equal to a constant, which we're going to call a. Therefore, c is equal to e to the power of negative q naught v t squared on 2 plus e 365 2 pi times a. Sorry, sine 2 pi t all over 365 times the a. That's the constant.
Hi, I'm David and I'm doing question 6. Question 6 asks us to prove the equation for finding pollution levels of 5% will equal the equation given using the solution we found in question 5. This equation that we have to prove to is the one that's listed above. Now, using the fact that no extra pollution is going into the lake and only fresh water is entering the lake, when we would look for a concentration level at time 0.05, this would be equal to 1/20th of the original concentration level at time 0. Now, substituting into the equation that we found earlier, and replacing t into t 0.05 throughout the equation, and make it equal to 1/20th of the concentration level at 0 time, would make the right hand side equal to simply 1/20. And so therefore we have 1/20 equaling the original side, the left hand side that is, and now taking the log of both sides, and cancelling out the negatives that we'll have from the exponential part of the equation, and taking the log of 1/20 gives us which, as we can see, is equal to the equation that we had to prove it to.
I'm Diga.
Hi, I'm Duygu. I'm doing question 7. In question 7, we are introduced to two separate lakes using the equation from question 6. And subbing in the given variables, we are able to plot a graph using computer software. We are trying to find a value for T when the pollution level reaches 5%. This is array. The point of intersection is at T 75.6025, and this is Ontario. The point of intersection is at T 130.983.